Okay, now that we've got our new repository, let's go ahead and actually use it. So I'll just close all this stuff down, and we're going to do our work in the user's controller for the time being. Currently, we're injecting our data context directly into this controller. Let's change that now, and we're going to make use of our iUser repository, and we'll just call it user repository inside our controller. So we're swapping our data context for this. Obviously, we've got some errors to clean up now, and it gives us an opportunity to take a look at what we're doing with our authentication here as well. So we're going to remove the allow anonymous, and we'll also remove the authorize from here, as we're going to say this user's controller, we want all of these different endpoints to be authenticated endpoints. So I'm going to say authorize inside here. Now bear in mind, once I've done this, if you go and take a look at your client application, then it's not going to be displaying any users because we still have not set up a way to send our token to the API. So possibly you might want to keep this as not authenticated if you're looking at your client app at the same time as we're doing the work here. I'm not going to be doing that. This section is entirely focused on the API, so I'm just going to keep it as authorized for my purposes. So our first request here is a request to go and get the users. And we're going to swap effectively context.users to list, and we're going to use our user repository and say get users async and execute that. And when we're using this repository method where we've got our action result, and it's always these action results actually, the type that we're using here, if we take a look at the error, says we cannot implicitly convert type system collections generic IEnumerable API entities, and can I see the further information app user to action result API entities app user. And there's no way around this really that gives us full type safety without getting this compiler warning. I don't think the action result was ever designed, or it never feels like it was designed to be used in this way, but that is typically how we would do this. But we can get around this quite easily because we can simply return OK and pass in the users as its value. And that is equally fine, by the way. It just means that our type safety isn't as good because the OK doesn't care what we put inside this. And we're also going to swap this one as well. Currently we've got this taking the ID as an int, but we're going to swap this for username, and I'm just going to specify username inside here. Don't be tempted to say username string. That doesn't work. We don't need to do it. A root parameter is a string by default, and we can stick with using username here. I've got ellipses here, but it's just telling me that this is currently unused. That's fine. So we're going to swap the parameter here for a string of the username instead of the ID, and we're going to swap this method and say await user repository and get user by username async and pass in the user name. And because this could potentially return null, because it's optional, then we still need our defensive check to make sure we have the user before returning the user. And for reasons only known to Microsoft internal developers, this one works fine when we're getting our user from the repository. It seems to be an issue with collections. So now that we have this in place, we can go test in Postman. So let's go back to, in fact, before I test in Postman, we definitely want to check the status of our code, and sure. Once again, .NET Watch says no, and we need to restart our app. So let's go ahead and do that. And our app starts successfully. Great. Okay, now we can go test in Postman. So just to be safe, I'm going to log in as Lisa again and get a fresh token. And then I'm going to go ahead and get the users. And we already know this was working for a previous lesson, but once again, we can just go and get our users. But we'll take a closer look at the response this time. So we've got our user object. Obviously, we've got information we don't want to be returning to the client, but we'll put that to one side for now. And we've got the date of birth. We'd prefer that to be an age. Okay, that's fine as well. We'll come back to that. But the photos array is empty. And do we have photos for these users? Well, I believe we do. And if I go to the database and just confirm this, and I'll open up the Explorer view and go to SQLite Explorer, and if we take a look at our photos table, then we do have photos in our photos table, and these are associated with the users in our database. So that means each user has a related photos collection. But where are they? They're not inside here. And let's just check to see if we get the same response when we check the get user by username. And if I click send, then we get the user back and the photos array is empty. So why is that? Well, Entity Framework is lazy by default. And unless we ask for a related entity, it's not going to automatically give it to us. Now, there's several options for this. And one of the options that we'll look at is to include or explicitly tell Entity Framework we want to include a related entity. And let's take a look at that approach. And we do this in the user repository. And if we go to our get users and get user by username, then inside here, let's just drop the toList async down. And above this, we can say include. What do we want to include with our users? And we can say x goes to x.photos, as this is the related entity that we want to include. And I'm just going to do the same with the username as well, or get user by username, and just include the photos with this one. So let's take a look at our terminal and see what is going on. And it looks like the app has just restarted. So let's go take a look and see what happens if I try and get a user by username. And disaster, we get an error. And it tells us that a possible object cycle was detected. This can either be due to a cycle, or if the object depth is larger than the maximum allowed depth of 32. And this is coming from our JSON serializer. So this isn't an Entity Framework problem. This is our JSON serializer, which is used by our API to return the data. So we'll take a look at what caused this and what we need to do to resolve this next.